This is the simulation file of our project. This is the input module for player 1 and this is the input module for player 2. Here we can see that 3 push buttons are used for each player. This one is for rock, this one is for paper, and this one is for scissor. We have implemented a logic so that a player can have only one input. If he uses multiple inputs, the input will be rejected. Then after the inputs are selected, the inputs are fed into this part. This is the logic circuit of the result. This detects the winner and the tie result and shows the result in these three LEDs. This is lit if player 1 wins, this is lit if player 2 wins, and this is lit if a tie is the result. After the result has been detected, these two counters come into action. If player 1 wins, a count increases here, and if player 2 wins, a count is increased here. If there is a tie, no count will be increased. This is the display module for player 1 and this is the display module for player 2. This generates the logic to generate the symbol for each player's input in the corresponding PCB. Here we can see 1, 2, 3, 4, 5 and 6 combinations. These combinations are these combinations make up the PCB. Now let's play the game and see what happens. Let's make player 1 input 1 and player 2 input 1 as well. We can see that no count is increased and the result is a tie. Now let's make player 1 choose paper instead of rock. Now as paper beats rock, player 1 wins and the count is increased to 1. And we can see that these three LEDs are now these three LED combinations are now lit. They will generate the logic to display a paper in player 1's PCB, and as player 2 has chosen rock, these combinations will generate a rock in player 2's PCB. Now let's see what happens when player 1 chooses scissor. Now as rock beats scissor, that is player 2 beats player 1, the counter for player 2 is increased to 1. Now let's see what happens when one player chooses multiple inputs. We can see that no LED will be lit now as the inputs are rejected and no results have been shown. This is the simulation file.
In our project, we implemented the popular game of rock, paper and scissors using logic gates and ICs. In our project, we have 8 basic modules. These two are input modules for player 1 and player 2. In the input modules, there are 3 switches for rock, paper and scissor input. We have implemented a logic so that one player can choose only one input. If he chooses more than one input, the inputs will be rejected. This is the logic circuit. This develops the logic of the result and shows the result in 3 LEDs. If the player 1 wins, then this LED is lit. If player 2 wins, this LED is lit. And if the result is a tie, this LED will be lit. Then these are the display logics. These generate the logics to show the symbol a player has chosen in the PCB. For example, if player 1 chooses rock, a symbol of rock will be generated here. Now let's play the game. Now let's see what happens when a player chooses an input. Let's make the player 1 choose scissor. Now in the PCB we can see that no display is shown, so that the player 2 cannot know what input has been chosen. Now let's make player 2 choose an input. Let us choose R. So we can see that rock has won over scissor and player 2 is the winner. In the counter for player 2 we can see that the count is now 1. Now let's see what happens when player 2 changes his input. Let us choose scissor instead of paper. You can see that scissor for player 1 is displayed here and scissor for player 2 is displayed here, and the result is a tie as shown in the LED, and we can see that the counter shows 1 and this counter shows 0 as no score has increased. Now let's see what happens when player 2 uses another input. Now let's make the player 2 choose paper. We can see that the paper is generated in this PCB and the scissor is displayed in this PCB, and as scissor beats paper, player 1 is the winner, and in the counter for player 1 the count is from 0 to 1. Now let's see what happens when a player chooses multiple inputs. Let's make the player 2 choose rock, for instance. We can see that both the PCBs are now turned off as the input is rejected, and as a result no result is shown by the LEDs. Now that is all in our project for rock paper scissors in DLD.